Assalamualaikum warahmatullahi wabarakatuh everyone, and welcome to another video lesson for physics. We are still in chapter number 3, which is all about dynamics. Previously you learned about stopping distance. Now we are going to talk about circular motion. So circular motion, from the name, is any type of motion or movement where the object is moving around in circles. It's not a type of rotation, but it's sort of like a movement where an object is moving around a center, a sort of center of the circle. So an example of a circular motion is this one here in this diagram. So this man is swinging around this piece of mass, we call it this object. This piece of mass is being swung around by this man, and this is a type of circular motion. How is the mass moving? It goes around in circles. Notice that it is rotating around a point, and the distance from the point to the mass is always the same. So in other words, the distance from the center of the circle, so in this diagram here, you can see the distance from the center of the circle to the object or to the mass is what we call this object, is always the same. So the distance that we mean here is the radius, so this distance here. So if the mass is moving around and then has reached this point, for example, let's say the mass is over there this time, the distance or the radius from the center of the circle to the mass is still the same because it's a circle. So the velocity of this mass is pointing in this direction here, like in this diagram. Uh, Whereas for the acceleration of the mass, the acceleration is pointing towards the center of the circle. So here I have a diagram of the mass at different points during its circular motion. So let me read out this part. Notice that the direction of the velocity changes when the mass is at different points on the circular path. So this is what the velocity vector looks like of the mass at each point during this circular path. So as you can see, the velocity changes at different points. Okay. Since the direction of the velocity is changing, this means that the mass is accelerating. So remember, in chapter 2, which is kinematics, acceleration is the change in velocity over time. So whenever there is a change in velocity, that means there is acceleration. So in this case, the velocity is changing in direction for different points. That means there has to be acceleration happening to this object. The direction of the acceleration is always towards the center of the rotation. Okay, so like in this diagram. So for this point, that is how the vectors look like for the velocity and acceleration. And then for the point down here at the bottom, that is what the velocity vector and the acceleration vector looks like for this point of the motion, right? So how do we know that the velocity is pointing towards the center? So I'll give you an example. Let's take this velocity and also this velocity, right? And we look at, by using vector analysis or vector diagram, we look at the difference between these two velocity vectors. Remember, acceleration is the difference in velocity. So if we look at the difference in its direction, that should tell us the direction of the acceleration. So let's call this vector vector A, and let's call this vector vector B. Okay, and let's redraw these two vectors and see what is the difference between these two vectors. So for vector A, it is pointing in this direction like that to the northwest. And then for vector B, it is pointing to the west like that. So what is the difference between these two vectors? If if you draw the difference is that one. Okay, and you can see the difference here is the same as this arrow here, this vector here. Okay, and that difference between the two directions of the two velocities is the same as the direction of the acceleration. And that's how we figure out the direction of the acceleration from the differences between the two velocities. Since force is equal to mass times acceleration, so that is Newton's second law, F is equal to ma, we can figure out the direction of the force. So we know the direction of the acceleration, we can figure out the direction of the force. And the acceleration is pointing towards the center, so the force must be the same. It is also pointing towards the center. And this force is known as the centripetal force. So the word centripetal means center seeking. In other words, it's pointing towards the center. For swinging the mass using the string, the centripetal force is the tension in the string. So let's go back to the diagram before, and I'll explain to you what I mean by that. So this is the diagram before. The guy is swinging the mass around. What are the forces acting on the mass during this motion? So you have one force that is pointing towards the center. Let me use a different color. So you have one force that is pointing towards the center, like that one, and this force is actually the tension force that is in the string. And this tension force is the centripetal force for this circular motion. Okay, so if there is a question that's asking what is the centripetal force for this circular motion, the answer will be tension. So centripetal force can be anything depending on the object that is doing the circular motion. Right, so the object is moving around. It's being swing around the center. What happens if you cut the string while the mass is still rotating? So where does it go? Where does it fly off to? If you cut the string, what will happen is the object will fly off in the direction that is in the same direction as the velocity. So in this case, it will fly off in this direction here that you see in this diagram. So that means if it is in a different position, let's say it's over here, and the velocity is in this direction. So for this spot here, the direction will be somewhere there. So that means if you cut off the string, this mass right here that I've just drawn will also, if you cut off the string, will fly off in the direction of the velocity. Okay, just like that. This means unless a force is pulling the mass to the center of the rotation, the mass would not keep moving around the center and simply fly away. So if there is if there is no force that is pointing towards the center, in other words, if there is no centripetal force, the object will no longer continue moving around in circles. So it flies off in the direction of the velocity. So in order for you to have a circular motion, the object needs to have a centripetal force, a force that is pointing towards the center. So that's the second paragraph here. In other words, a centripetal force is needed for circular motion to happen. So every time there is circular motion, there is always a centripetal force, right? So, and also you might want to write this down in your notes. The the resultant force is always the centripetal force. So the resultant force is always the centripetal force during a circular motion. Okay, so in other words, when an object is moving around in circles, there may be a lot of forces acting on the object, but if you add up all the forces to find the resultant force, this resultant force is always pointing towards the center. In other words, the resultant force is the centripetal force. Okay, I hope you understand that one. Okay, so there are a lot of different types of circular motion. So we just saw in the beginning, a man swinging around an object is a type of circular motion. The orbit of planets is also a type of circular motion because they are moving around in circles. I'll explain about orbits for this part. The 9 planets, the moon and satellites all circle around a larger object. The planets move around the sun, the moon circle around the earth, and the satellites rotate around the earth. The circular path that they follow is called their orbits, and they stay in their orbits because of the force of gravity. So the reason why they go around the circle, the reason why the earth is orbiting around the sun is because of the gravity between the earth and the sun. That's why it's moving around around in circles. Gravity depends on two factors, the mass of two objects and the distance between the two objects. The greater the masses of the two objects, or the closer they are, the stronger the force of gravity. So that means if you have a heavy planet with with a heavy sun, then that means the gravity will be stronger. If they are closer together, then that also means the gravity is stronger. For the planets orbiting around the sun, the centripetal force is the gravitational force. Right? So here is a diagram of the Earth moving around the sun. It's moving around in its orbit. So that is also known as a type of circular motion. And the reason why they are moving around in circles is because there is a gravitational force between the Earth and the sun. And this gravitational force is always pointing towards the sun, like that one, towards the center of the circle. So that's gravity. And also, this gravitational force is also the centripetal force for this circular motion. Okay, so the gravity is the centripetal force. Let's talk about satellites. A satellite is an object that orbits around a planet or a star. The Earth has two types of satellite. Man-made satellites, yes, that's right. A satellite is not only a type of machine, but it's anything that is orbiting around the planet or a star. So you have man-made satellites. These are the communication satellites, weather forecasting satellites, space stations, and so on. And you have natural satellites. Yes, the moon is also known as a satellite for the Earth. So these are natural satellites. The Earth's satellites are able to rotate around the Earth because of their interaction with the Earth's gravity. Again, they are orbiting because there is gravity between the Earth and these satellites. The speed of the satellites determines its orbit. If the satellite is fast, its orbit is closer to Earth. If the satellite is slower, its orbit is further away from the Earth. So you can see in this diagram, if it's fast, then that means it will orbit closer to the Earth. If it's much slower, then it will orbit further away. Okay, like this diagram here. Communication satellites orbit the Earth at a certain height above the equator with a certain speed that makes sure that these satellites will rotate the Earth in 24 hours. So these satellites, they orbit around the Earth and they have to cover the Earth in 24 hours so that to make sure that there is a signal established between the communication satellite and also the devices on the ground or on the Earth. Weather forecasting satellites are in low orbits. That means they are moving around the Earth much faster than the communication satellite. Why do they have to move around much faster? That's because, again, they are there to give information about the weather as soon as possible. Okay, so they need to go around the Earth as quickly as possible. This is so that they can scan the surface of the Earth quickly and also give us the information of the weather quickly. The moon orbits far away from the Earth, as so it moves slowly. It is so slow that the moon takes about 27 days to completely go around the Earth. People a long time ago noticed this rotation and created calendars which uses months that are actually based on the movement of the moon. So the reason why we have 31 days in a month or 28 days in a month, that's because that is how long the moon takes in order for it to go around the Earth. So we base our months based on the movement of the moon. The planets orbiting the sun also follow the same rule. the further away a planet is, the longer it takes to complete a circle around the sun. So if a planet is further away, for example, like in this diagram, Jupiter is much further away, Jupiter will go around the sun at a much longer time when compared to the Earth, because the Earth is closer to the sun. Earth takes 365.25 days to rotate around the sun. So if that number is familiar for you, that is actually the number of days in 1 year. So we base our number of days for a year based on how many days it takes for the Earth to go around the sun. And in this case, it is 365 days. Whereas for Mars, because it's a bit further away from the sun, Mars takes 687 days to rotate around the sun. Another type of circular motion is between electrons inside an atom. So you can see, and you have probably learned this in chemistry, so the electrons inside an atom is always orbiting around the nucleus of the atom. So electrons also move in orbits. The electrons move around the nucleus. The centripetal force, so there is a force here that is causing the electron to move around in circles. And this force, which is the centripetal force, is the electrostatic force between the electron and the nucleus. So if I were to draw what does the force look like here? So that's the electron, and the force will be something like that. Okay, the force is pointing towards the center. And in this case, this is the electrostatic force. And this is the centripetal force in this case for this circular motion. Okay, if there is an exam question and asking what is the centripetal force for an electron in an atom, the centripetal force is the electrostatic force. And that is basically everything that you need to know about circular motion. So to summarize, for an object with circular motion, the resultant force acts in a direction that is towards the center. So if you have an object moving around in a circle, there might be a lot of forces acting on the object, but if you calculate the resultant force, or if you find out what is the resultant force, the resultant force of all those forces acting on the object will always point towards the center, and the resultant force is what we also call as the centripetal force. The acceleration vector is in a direction that is towards the center of rotation. So just like the centripetal force, the acceleration is also pointing towards the center. Whereas for the velocity is pointing in a direction that is perpendicular to the direction of the acceleration. So if you look at here, the velocity and the centripetal force, they are 90 degrees from each other. So in other words, it is perpendicular. Perpendicular means it's 90 degrees. So you can see here. So there are also a lot of different types of circular motion, and the ones we looked at in this topic are listed in this table here. So for a mass that is rotating, that is tied to a string, what is the centripetal force? It is the tension inside the string. For planets orbiting around the sun, what is the centripetal force? It is the gravitational force. For electrons in atoms moving around the nucleus, what is the centripetal force? That is the electrostatic force. Okay, and that is everything on circular motion. So I hope you understood what I just explained. And that is the end of chapter 3, actually. So next chapter, we will go on to talk about mass, weight, and also density. So until then, thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.